Okay, algebra. Today you are going to be learning how to solve systems of equations by graphing. And a system of equations is what you're seeing on the screen, and that's where you have the brackets like that. What that means is whatever x and y are in the first equation, they are the same thing in the second equation. So these, it's called a system of equations. So if in the first equation x is 3, then x is 3 in the second equation. So they have the same solutions. This is all on page 250, and you do want to take notes. This is called Systems of Linear Equations by Graphing, and you can follow along in your book. It's the same examples as you write them down, and we'll put them in your notebooks later, so just hold on to this page. Okay, so for example 1, we're going to determine whether the point 12, 6 is a solution to the system. In order to be a solution, you're going to plug in the values, just like we do when we see if it's a solution to a single equation, and there's the bell. And it is a system to the, or it's a solution to the system if it's true for both equations. So you're going to write has to be true for both. Okay? Okay, so it has to be true for both. So what we're going to do is we're going to plug in 12 for x and 6 for y in the first equation and see if that works for the first equation. So I'm going to say 2 times 12 minus 3 times 6 equals 6. And 2 times 12 is 24. And 3 times 6 is 18. So I have 24 minus 18 equals 6. And 6 equals 6. So it works for that one. Now I want to check to see if it works for the second equation. So what we'll do is we'll plug in 12 for x and 6 for y. So I'm going to write 12 equals 2 times 6. And since 12 equals 12, it is true for the second equation, so you would write yes. So it is a solution to the system because it works for both equations. If it was no for either equation, then it's automatically no. So let's look at another example. Example 2. So we're going to plug in -1, 2 into each of our equations. So in the first one, we're going to say 4 times -1 minus 2 equals 2. And 4 times -1 is -4. -4 minus 2 equals 2. -4 minus 2 is -6. So we end up with -6 is 2. Since it does not work for that one, then the answer to the whole thing is no. Because if it doesn't, you don't even have to check it with the second one. If it doesn't work for one, then it doesn't work for both. That's it on that. So example 3, we're going to be solving the systems by graphing. So this is pretty easy. This is the easiest way to solve a system of equations. And so what we're looking for is we're looking for what ordered pair will be on both lines. So what that means is what ordered pair is where these two lines cross. So what we want to do is first put the equations, in slope-intercept form. So on that first one, I'm going to move the x over to the right side. So I'm going to write 3y equals positive x plus 10. So all I did was I added x to both sides right there. Okay. And now I want to divide by 3. So I'm going to divide them all by 3. And this equation equals y equals, and so x over 3 is the same thing as saying 1/3 x. And 10 over 3 is the same as 3 1/3. I'm going to go ahead and change it like that so it's easier to graph. For the second equation, I want to put it in slope-intercept form as well. I just need to move the x over. So I end up with y equals -x plus 2. So now what I'm going to do is I'm going to graph both of those lines on a coordinate plane. And Mrs. Birtles has sticky graphs for you to do this. So I'm going to graph 1/3 x plus 3 1/3. So I'm going to write that here. Whoops. Y equals 1/3 x plus 3 1/3. Okay. I'll draw my lines. I can do it there and there, okay? And, you know, it would annoy me if I didn't have arrows. Okay, so I want to put this on the coordinate plane, and so my y-intercept is 3 1/3, which isn't super friendly, but that's okay. So I'm going to go up 3 and just a little bit more. And then the slope is 1/3, so up 1 over 3. So I'm going to go up 1 over 3. I'm going to do it one more time. So it's about like that. Oops, didn't draw Okay, and when you do this, you want to be really careful about drawing your lines nice and straight so it's easy to see. The second one is negative x plus 2. So I'm going to put that on my graph. And so my y-intercept is positive 2, so I'm going to go up 2. And negative x means my slope is negative 1 over 1. So I'm going to go down 1 to the right 1. It's going to keep going like that. So it's going to cross like this. Okay, now if I had drawn my lines super good and straight, they would have crossed at this point right here, because this is really supposed to be up just a smidge more. And so if I drew my lines right through those dots, you would see that it would cross right there. So that is my solution right there, and I'm going to write that as an ordered pair. And that means I'm going to go right 1, so that's negative 1, and then up 1, 2, 3. And that's where they cross. This is the answer. Negative 1, 3 is the solution to the system. Okay, so moving on to example 4. So to solve this system of equations, we're going to graph both of our lines. So the first thing we need to do is to put this one in slope-intercept form. So I will subtract 2x from both sides. So what I'd have is 3y equals negative 2x minus 2. And now I'm going to divide both sides by 3. Divide by 3, divide by 3. And I get y equals negative 2/3 x minus 2/3. So that is that equation, and my other one is already done. It's just x equals 2. So that should be a clue in our ordered pair that the x is going to be a 2. But let's put this on a graph and we'll see what our final answer is. So negative 2/3 x minus 2/3. So I'm going to draw my axes. And of course my arrows. And now I had negative 2/3 x minus 2/3 for the first one. That's y equals. So negative 2/3 means down to about right there. So not quite down to the 1. And then if I'm going to go up or down 2 over 3 for my slope is negative 2 over 3. So I'm going to go down 2 over 3 about right there. Down 2 again over 3 about right there. So these ones with fraction ones, you just have to do your best to make it as accurate as possible. Okay, like that. And then our second one, it was x equals 2. So that's a vertical line on 2. Change my color here. So vertical line on 2 is going to go like that. And if I did that really well, which you want to make sure you really do your best at it, it's crossing right there at that point. Okay, which means that x was 2, which we'd already decided, and then y is going down negative 2. So our solution to this inequality, or to the system of equations, is 2, negative 2. So you're going to graph both of the lines on the same coordinate plane, and where they cross is your solution. So let's look at the next example. Example 5. So first thing I need to do is put both of my equations in slope-intercept form. So my first one, I just need to move the 2x over to the other side. So I end up with y equals negative 2x plus 7. And I don't know why I wrote a 2. I was looking at something else. And for my second one, all I need to do is just divide both sides by 2. So my second equation is y equals, and then negative 4 over 2 is negative 2. So y equals negative 2x. So now I'm going to graph both of these lines on the coordinate plane. So negative 2x plus 7. Let me draw my axes. Oops. Whoops. There we go. And that. And I had, well, I can't remember the line now. So negative 2x plus 7 and negative 2x. So negative 2x plus 7 means I have a y-intercept of 7. So 1, 2, 3, 4, 5, 6, 7. And I'm going to go down 2 over 1, down 2 over 1, and then draw my line as straight as you can. And then my other one was just y equals negative 2x. So on this one, my y-intercept would be, since I don't have anything there, it's just like saying plus 0, so I start at the origin. and I just go down 2 over 1 for my slope, down 2 over 1. And what I end up with is I end up having two lines that are parallel to each other. Because they have the same slope, if you remember from when we could tell whether two lines were parallel, perpendicular, or neither, when they have the same slope, they're parallel. So your answer isn't going to be parallel because the solution should be, where are these two lines going to cross? Since they are never going to cross because they are parallel, you're going to write that there is no solution. There is nothing that would go in for x and y in both equations that would make both of these equations true because they never cross. So when you have parallel lines, the answer is no solution. Okay, so I'm going to write that down. Parallel lines have no solution. And I know that's really sloppy, but you're hearing me say it, so you know what I'm trying to write. Okay, so parallel lines have no solution. So make sure that you always write no solution when you're working it out when you have parallel. I don't want to see the word parallel as your answer. Okay, last one before everyone comes in here. Example 6. We're going to solve both of these equations for y. So the first one, I'm going to just subtract x from both sides, and I get negative y equals negative x plus 3. And now I'm going to divide everything by negative 1. So I get y equals x minus 3. Now my second one, I'm just going to add x to both sides. So I'm going to write plus x here, and I get y equals x minus 3. So what you're seeing is that both of them turn out to be the same equation. So if I were to graph these lines on here, if I were to graph both lines, since it's the same line, that'd be like graphing the same thing twice, right? So that means that our two lines are on top of each other. They're both y equals x minus 3, so my y-intercept is 3, negative 3, and then I go up 1 over 1, up 1 over 1. And so if I wanted to graph the second one, since it's the same line, well, that's really bad, but you get the idea. Since the second one is also on the same line, everywhere that they cross, they each have, every point that they cross is the same on all of them. So what you say for the solution is not all real numbers, but we have infinitely many solutions. Because what that means is every point on the line is a solution, because every point on the line would be on both lines. So the answer would be infinitely many solutions. That's it, and hopefully that's enough, and I will give Mrs. Birtles your homework. I'll see you guys tomorrow. Bye.